let us discuss a few points about normal distribution, which we designate with the density function this. This is the most general form of the density function for normal distribution. Now, if we put y in place of x by sigma minus m by sigma, then these effects turns out to be, see, we have put x minus m by sigma equal to y. So, this will turn out to be 1 by sigma root 2 pi e to the power minus y square by 2. So, you can easily relate that what we have done here is origin shift and scale change, which you student of statistics must know and must apprehend the utility of shifting the origin as well as shifting the scale of measurement, and with that we can transfer this to this. What is the advantage? The advantage is that we can establish that this is equal to 1 more easily than this form, nothing else than that, because we all know that e to the power minus y square by 2 dy is equal to root 2 pi. Okay, this is equal to root 2 pi. Oh, this sigma is not there, since we have substituted with this will become like this, Fy will look like this. We have changed the scale. Now, we would like to show the characteristic function of the normal distribution. The characteristic function phi t is defined as expectation of e to the power I t x, and this can be evaluated like this: e to the power I t x into e to the power minus x square by 2 dx, and this can be evaluated if we write this as this. We have added I square t square and subtracted I square t square. If we take minus half common from these two terms, we have x square minus 2 I t x, and these three terms makes it x minus I t whole square, and I square is minus 1. So, this becomes plus t square by 2. When multiplied with minus half, this becomes minus t square by 2. So, if we write this, we have e to the power minus half x minus I t whole square into e to the power minus t square by 2 dx. And since this is, we can evaluate this as to be 1. So, we can write it as, I have forgotten to write the 1 by root 2 pi here, and this can be written as e to the power minus t square by 2 only, because it comes out of the integral, and this integral is evaluated as root 2 pi. So, characteristic function is this. So, these are the basic traits of normal distribution. Possibly you all know this and will learn in your probability course. Still, I would like to mention, and we also know that phi LT is expectation of I to the power L, x to the power L and e to the power I t x. Since we know that phi LT stands for the derivative of Lth order of the function phi with respect to t, and since phi t is defined to be the characteristic function which is integral of e to the power I t x, phi t is expectation of e to the power I t x, which is nothing but e to the power I t x f x dx, where f x is the density function of the normal distribution. So, if we take the derivative to the lth order with respect to t, and this is differentiation under the sign of integration, which gives us expectation of e to the power I to the power L, x to the power L, and this comes out to be the formula, which I am not going to write here. You know this. Remember that ML is nothing but this. As we know, I to the power L comes out of the expectation symbol and things look like this. You should remember this. You should also remember the effect of origin shift and scale change. That is, if we put y equal to ax plus b, that is the scale change and origin shift. I hope you understand. Then what is the effect on this characteristic function? Just see, if phi t is the characteristic function of x, then we may write it as phi x t. Then what is it? It is e to the power I t x f x dx. So, in case of normal distribution, it becomes 1 by root 2 pi e to the power I t x e to the power minus x square by 2 dx. Okay. So,